Curvilinear coordinate systems 8 derive the scale factors for the cylindrical and spherical systems, also derive the expressions for the gradient, divergence, and curl operators in these systems. So first we did the cylindrical system, now we're going to do the spherical system. The spherical coordinate system, we can write our position vector r as for x we have r sine theta cosine phi. This is in ex hat direction. And then we have the y component r sine theta sine phi in ey hat direction. And then we have r cosine theta in ez hat direction. So that's the position vector. Now we're ready to start taking the derivatives. So we can first do del position vector del r. Let's think about it for a moment. So we will have from this term sine theta cosine phi, from this term sine theta sine phi, and from this term cosine theta. So this is sine theta cosine phi in ex hat direction plus sine theta sine phi in ey hat direction, and then we have cosine theta in ez hat direction, and the corresponding scale factor is the magnitude of this derivative del r, del position vector del r, and that scale factor h sub r is, now you can see that we're going to get sine square theta parentheses cosine square plus sine square of phi, and then we will get cosine square theta. So sine square theta cosine square phi plus sine square phi parentheses, and then we have cosine square theta, and this is going to be all inside the square root. Now sine square plus cosine square is 1, and sine square plus cosine square is 1. Therefore, we obtain our scale factor h sub r is equal to 1. Our first scale factor is 1. Then we're going to take a derivative with respect to theta, del r del theta. Let's take a look at the position vector again. The theta derivative will give me r cosine theta cosine phi, r cosine theta sine phi, and here I'm going to get minus r sine theta. So del r del theta is r cosine theta cosine phi in ex hat direction plus r cosine theta sine phi in ey hat direction, and then I have minus r sine theta in ez hat direction, and the corresponding scale factor h theta is the magnitude of this vector del r del theta magnitude. Now if I look at the magnitude of this vector to find my scale factor, here I have r square cosine square theta parentheses cosine square phi plus sine square phi, and here I get r square sine square theta. So r square comes out of the square root. So I have r cosine square theta parentheses cosine square phi plus sine square phi, and then I have the last term sine square theta. This is all inside the square root except the r, and therefore I obtain, because this is 1 and cosine square plus sine square is 1, I obtain the scale factor h theta to be equal to r. And finally, let's work on this scale factor h phi. Now I take a derivative of the position vector with respect to phi. I obtain the derivative with respect to phi will give me a minus r sine theta sine phi plus r sine theta cosine phi, and here there is no phi term. The derivative is 0. So I have minus r sine theta sine phi in ex hat direction plus r sine theta cosine phi in ey hat direction, and the corresponding scale factor h phi is the magnitude of del r del phi Now we're ready to write h phi here. H phi is equal to, now you can see I have r squared sine squared theta parentheses sine squared phi plus cosine squared phi. So r sine theta comes out of the square root. I have sine square phi plus cosine square phi inside the square root, which is 1. Therefore, I find my scale factor h sub phi to be equal to r sine theta. Okay, now we're ready to work on the gradient qi hat over hi del del qi. So applying this to our spherical coordinates, the gradient operator will become, for er hat divided by hr del del r plus e theta hat divided by h theta del del theta, and then we have e phi hat divided by h phi del del phi. Okay, now we can substitute the scale factors, the gradient operator, and spherical coordinates is going to become, the scale factor hr is equal to 1, so we have er hat del del r. The scale factor h theta is equal to r, so we will have 1 over r. So e theta hat 1 over r del del r, and the scale factor h phi is r sine theta, so we will have plus E phi hat 1 over r sine theta del phi. So this gives us our final answer for the gradient in spherical coordinates. Now let's work on the divergence. Now divergence is given in this form, so I just have to substitute the scale factors here. Divergence of A will be 1 over product of the scale factors, which is 1 over r square sine theta. Then I have del r. HR was 1, but the others were r and r sine theta, so this becomes r square sine theta, r square sine theta a sub r, plus del theta. Now I have HR, which is 1, but H phi is r sine theta, so this is r sine theta a theta. And for the phi part, I have del phi HR H theta. H theta was equal to r, so this is just r a phi. Okay. All right, so if I distribute this into the parentheses and rewrite my divergence here, divergence of A is equal to, the r derivative doesn't affect the sine theta part, so that will cancel. So I will be left with the first term, 1 over r squared del r square AR del r. As for the second term, you can see that r is not affected by theta derivative. So this will make this 1 over r sine theta. So the second term is 1 over r sine theta del sine theta a theta del theta. And the last term, I have a phi derivative of the r, but r is unaffected, so that will get to the one of the r's here. So I will have also plus 1 over r sine theta del a phi del phi. So that's the final answer for the divergence in spherical coordinates. Now, as for the curl, once again, we have to take this determinant. So I'm again substituting the product of the scale factors, 1 over r square sine theta. Then I have to take this determinant. Let's see, HR hat is just ER hat. Then I have del R, HRAR is AR. Then I have H theta E theta hat, which is R E theta hat, del theta, H theta A theta, which is R A theta. Then I have H phi E phi hat, which is R sine theta E phi hat, del phi, and r sine theta a phi. So we have to take this determinant with respect to the first row, let's say, so plus minus plus. Okay, so the first term will be 1 over r squared sine theta parenthesis er hat times del theta of r sine theta a phi minus del phi of r a theta. So let's do that here. Curl of A is equal to 1 over r squared sine theta, square brackets, del theta of r sine theta a phi minus del phi of r a theta. And this part is in er hat direction. Then now we can do the second term. So we did this del theta of r sine theta a phi minus del phi of r a theta. Now we're going to do a minus r e theta hat. So because of the minus sign, instead of evaluating this first, we can evaluate this first. Del phi a r minus del r sine theta a phi. The r also will cancel this. So I'm going to get plus 1 over r sine theta del ar del phi minus del r of r sine theta a phi. And this is in e theta hat direction. So I've taken care of the r e theta hat by canceling this r. And the last term is r sine theta e phi hat times del r a theta minus del theta a r. So r sine theta will get rid of this r sine theta and leave me just an r. So the third term will become 1 over r del r a theta del r minus del ar del theta. This is in e phi hat direction. Okay, now if I distribute these factors inside to see what's going to happen, I can write my final answer for curl A. Curl A becomes, for the first term here, I have a theta derivative and an r here, so r is unaffected, so that will get rid of this one. So first I will have 1 over r sine theta. And the same thing will happen here. The phi derivative doesn't affect r, so this is also 1 over r sine theta. So 1 over r sine theta parentheses, I have del sine theta a phi del theta minus del a theta del phi in er hat direction. All right. Now the next term here there is nothing to do, so this will be plus square brackets. I have 1 over r sine theta del AR del phi. And let me think about this term. And r derivative, sine theta is unaffected, so sine theta will cancel. So I will have minus 1 over r del r a phi del r in e phi hat direction, e theta hat direction. And the last term, actually this r derivative is affected here, so nothing will change in the last term. So I can just copy this last term. Copy. This is the last term. Therefore, this is my final answer for curl A in spherical coordinates. Alright, so basically I have followed the same procedure. First, write the position vector using the transformations from spherical to Cartesian coordinates. Take derivatives with respect to r, theta, and phi. Evaluate the magnitudes, giving me the scale factors. Gradient operator is qi hat over hi del del qi. That's what I have done here. Divergence 1 over hr h theta h phi. The del del r h theta h phi ar plus del del theta hr h phi a theta plus del del phi hr h theta a phi. So that's what I have done here. And finally, to take the curl, 1 over product of the scale factors, the unit vectors pre-multiplied by the scale factors hr er hat, h theta e theta hat, h phi e phi hat, partial derivatives, and then the components of A with respect to spherical coordinate axis pre-multiplied by scale factors, and taking the determinant and doing some manipulations here, I've obtained my final answer for the curl in spherical coordinates.